Hi, today we're going to be talking again about probability, and I'm going to give an example. So in this example, we have the following scenario. So in this scenario, we have a light bulb who on average has a lifetime of 1,000 hours. Okay, and we model this lifetime with an exponential distribution. So the first question here, A, is what is the probability the lifetime x is less than or equal to 400 hours? Okay. Now, to calculate this integral, well, it'd be the integral from minus infinity to 400 of f of x dx. But we need to know what is f of x. Well, the fact that we specified the distribution with exponential means, hey, the density function f of x is going to be 1 over mu times e to the minus x over mu for x greater than 0 and 0 else. This is an exponential distribution. So this corresponds to the exponential distribution, and we use that formula. And we'll specify one more thing. It says the mean mu is 1,000, so mu is equal to 1,000. So now we're ready to calculate probability. Notice it didn't specify the formula, it just referred to an exponential distribution. Since it said, hey, this is the exponential distribution, we know that all exponential distributions have the form given in the highlighted red. Okay, well, first note, this density only applies for x greater than 0, so it's the integral from 0 to 400 of f of x, which is going to be 1 over 1,000 times e to the minus x over 1,000 dx. We can anti-differentiate this just by doing a u substitution. U is equal to minus x over 1,000. Or we can recognize that it will be minus this integral of minus x over 1,000. And we evaluate at 400 and 0. When we evaluate this, this will be minus e to the minus 400 over 1,000 minus a double negative of e to the 0. So that's 1 minus e to the 4/10. And now we just type that into a calculator and figure out what that number is. And that's approximately 32.9%, or 0.329 is what it would appear as. Okay. Excuse me. Yes. So 0.329. Now, we could also ask, hey, calculate this probability. What's the probability x lasts longer than 900 hours? Well, this is going to be the integral from 900 to 1,000 of f of x, which is 1 over 1,000, times by e to the minus x over 1,000. We should notice this is an improper integral, so we'll take the limit as b goes to infinity of 900 to b of 1 over 1,000 times by e to the minus x over 1,000 dx. We can anti-differentiate this, and we'll get the following. Minus e to the minus x over 1,000 evaluated at 900 and at b. This is going to be the limit as b goes to infinity of minus e to the minus b over 1,000 plus, because the double negative, e to the minus 900 over 1,000. And the limit is 0. The second number is 0.407, so 40%. Okay, let's do one more. Now we can ask this question: what is the median lifetime of the bulb? Well, the median has the following property. The probability x is less than the median is equal to 50%. The median is the point that divides the data set into 50% probabilities. 50% above, 50% less. Well, this just means that the integral from 0 to m of 1 over 1,000 times by e to the minus x over 1,000 dx is equal to 1/2. Well, we anti-differentiate this, and we're going to get minus e to the minus x over 1,000 from 0 to m. That'll be minus e to the minus m over 1,000 plus e to the 0 is equal to 1/2. Well, we'll do some algebra, and this says e to the minus m over 1,000 is equal to 1/2. So that says m is equal to 1,000 times this ln of 1/2, and that'll be a negative 1,000, and that's approximately 693.1. And this is in hours. So this is how many hours the light bulb is expected to last for at least 50% of the observations. Okay. Notice that the mean and median are different values. That's pretty typical for an exponential distribution. Thank you very much.